we're looking at 2.1. This is my second attempt, by the way, of doing this. I just didn't like where I was going. So we're at 2.1, the difference quotient, and we're going to look at the derivative, which right now means nothing to you. But now that we have this concept of limits understood, what we'll be doing is looking at, well, what if somebody were to ask you what the tangent line is of a curve, which right now probably doesn't mean anything to you, but you know, if you were to have a curve that maybe looked like this, and somebody were to look at you and say, oh, well, what's a tangent line right here? Well, if you remember from geometry, the tangent line hits that curve at exactly 1 point. So you might look at that point and say, oh, well, it looks like it's positive. It has a positive slope at that point. But if somebody were to ask you to find the exact value of that slope, you might have to go to your slope formula. You know, y2 minus y1 over x2 minus x1. Well, that's nice and all as long as we have 2 points. Well, if it only crosses this point at exactly one spot, well, the y-coordinates will be the same, the x-coordinates will be the same. So if that's the case, we're going to end up with 0 over 0, which we just learned with limits. You might be able to find that value, but right now it's just indeterminate. So what can we do in calculus? Well, what we could do is we could say, okay, well, let's say that I'm going to make it purple now. I'm going to call that x. Well, what we could do is we could find another point on this curve. All right, and I'm going to kind of cheat and look at the next one. We could say, okay, well, this is h units further. All right, so what does that mean? Is that this new x-coordinate is x plus h, right? X to get right here, and then add h to it to get right here. So what are my points now is, whoops, I put my f in the wrong spot. F of x plus h, and this value, I'm talking about y values, by the way. This is like if we knew what the function was, we could plug in x plus h in for x and do f. And then this point would be f of x. Okay, well, what that actually does is because it cuts through the curve, this is called a secant line. So let me draw that real quick and label it. It's called the secant line. I guess I should have gone back and called this my tangent line. And right now that's a terrible approximation for the slope, correct? This is a negative slope for the secant line. Well, how can we make that answer better? Okay, well, what if instead of h going right here, maybe we shortened it up a little bit and made h go to right here? Okay, well, now it'd be right here. And then my secant line, I hope you would agree, is a little bit better. Well, even though that one's not very good, what if I just made h go like right here? So now right here is my secant line. I hope you see where I'm going with this. Let me switch over to gray. Well, what if you had your secant line be infinitely small? Well, if it's infinitely small, then your secant line might line up perfectly. So what I'm getting at is your h value needs to be as small as possible to get there, and then you could actually work it out. Now, you might be sitting there and saying, well, how would I find, let me go back to purple, how would I find the slope? Well, easy, because the slope is your y-coordinate minus your y-coordinate, because we care about f of x, right? We cared about that to begin with, over the x-coordinate minus the x-coordinate. And, well, that's actually what this next problem is. What we'd be finding here is the slope of the secant line. Well, we can then simplify that because x minus x would cancel, and we're just left with f of x plus h minus f of x all over h. So the premise is the smaller the h gets, the closer and closer we get to the tangent line. In other words, the limit as h approaches 0, the smaller and smaller it gets, then we're going to get closer and closer to the slope of the tangent line. Sorry, I kind of skipped this middle question, but that's essentially what we're doing. So what we could then do is use what we've actually practiced already, this top piece, and we could actually perform a limit as h approaches 0. And you probably remember my advice from earlier in the unit, that to leave h alone on bottom, to leave f of x alone. Notice that I'm putting in parentheses again. I accidentally kept them the same. And then change f to be, I did not give myself enough room. There we go. Replace my x's with x plus h. And as you simplify that, limit as h approaches 0, well, I'm going to do several steps at once because I'm already run out of space. That's x squared plus 2xh, but I'm going to distribute that minus in there as well, and then plus h squared, but distribute that h negative in there, excuse me, minus 4x minus 4h plus 1 plus x squared plus 4x minus 1 all over h. This is where a lot of magic happens. X squareds cancel, 4x's cancel, 1's cancel. You'll notice in the numerator, let me write this right here, so we still have the limit as h approaches 0. Let me just kind of move my equal signs like this. You can factor out an h with what's left over. You're left with negative 2x minus h, what's that, minus 4. I'm going to have to move my screen over a little bit. Sorry about that. All over h, so that we could cancel out these h's. Now I can do direct substitution, and I'm left with negative 2x minus 4. And what we just found is the equation of any tangent line at these points. So let me take a moment and explain what this means. And I'm going to use Desmos to explain it. So let me pull that up real quick. So I went ahead and graphed this curve. So what I can do is I can say, type the answer we got, negative 4x minus 4, which right now doesn't look like anything. But what I'm going to do is hide this for a second. What these values are telling me are the slopes at that point. So the blue curve is what we started with. The green line is finding the slopes of the tangent line. Well, if I were to ask you what the slope is at this ordered pair, negative 1, 3, I hope you'd all say that the tangent line would be a slope of 0. And that's exactly what this gave me. When x was negative 1, the slope was 0. Now, I wouldn't expect you to know the slope when x equals 0 on this problem. But if I were to find it using the green equation, the answer is negative 4. So let me hide that equation. So remember that my slope is negative 4. Let me hide it, create a new equation. So I'm just going to make the equation y equals negative 4x plus 1. You can see as I zoom in that I wish it was a different color. Make it more of a, I don't know. None of the colors really work for me. But this orange line is only going to hit that blue curve at exactly 1 point. And I could do that with this value over here at x equals -2. Let's see, at x equals -2, what does it say? It has a slope of 4. So I'm going to write another equation, y equals 4x, but I'm going to shift it up. Let's see, plus 8, nope, that's not good enough. Plus 10, nope, that's too much. Plus 9, and let me zoom in, and you can see that it hits perfectly at that point. I'm going to show you how to find those values here shortly, but right now that's where we're at. So a quick answer to the next question is what we just found is the derivative. So what we just found is the derivative, and this is the notation we use, one of many notations, I guess I should say, -2x minus 4. And what it does is it finds the slope of the curve at that point. Actually, let me write that down. The derivative finds the slope of the tangent line of the curve at that point. So feel free to pause the video at any point, go back and rewatch, and make sure you're getting this, all right? So this is essentially what we just talked about. So, you know, I just messed with -2. What other values did I mess with? I think I did -1. No, I did not do -1. But if we were to plug in -1 into this problem, we would end up with -2. So f prime of -1 equals -2. So if you were to draw a tangent line right there, you should see that it has a slope of approximately down to right 1. Same thing with this one. F prime of -2, well, when you plug that in, it should give you 0. Does the slope at x equals -2 look like a horizontal tangent? And then f prime of -4, well, that would be 8 minus 4, so that's 4. So this slope should have been like up 4 over 1. 1, 2, 3, 4 over 1. So a very steep curve is the point. So I'm going to get the definition up here, and I'm going to hit pause. And I know I kind of wrote this down, but it never hurts to hear it and write it twice. So here's the answer key sharing with you the definition of the derivative and what it represents graphically. And again, feel free to hit pause at any point and write this down. This is all good, important stuff. So the derivative, also written as f prime of x, is a function that results from the limit as h approaches 0 of that function f of x plus h minus f of x all over h. And that can be used to find the slope of any tangent line drawn to the graph of f of x. So I'm going to stop the video, so you better pause it quickly. Copy this down. All good things.